So if you go back to look at number 45, we have x plus 2 to the 8th. They want to know what the x to the 4th term is. In this one here, if you want to figure out what the x to the 4th term is, you know that since the x value here is raised to the 1st degree, you don't have to do anything crazy with it. So you start by putting x to the 4th. We know we have an 8c something, because this number here is always the same number here. The two numbers here with the 2, these two exponents, this one and this one, have to also equal 8. So 4 plus what is 8? 4. And then this number that's here goes here. Sure. Okay. Same thing goes for the one after it. The one after it was it x squared plus 3, I think? Or was it 4? 4. It was to the 10th, and they wanted to figure out what the x to the 6th term is. Now, in this case, you've got your first value of x squared. You have to figure out x squared to what power is x to the 6th. So x squared to some power is going to equal. So this has to be 3. Okay. So then this will be 4 to what power then? 3 plus what is 10, so it would be 7. And this is a 10C7. It'll work every time. Every single time. That's all you got to do. Correct. You guys got to watch out for when it sets up like that. That's all you have to do with that. That's the answer. Yeah. That's all you have to do. I did. You guys were all just mad at me about it. Okay. Same idea. If it's x, let's say it's x squared minus 3 to the 13th, and I want to figure out what x to the 4th is. Okay, if it's x to the 4th, that means it's x squared squared. And then that'll be times the negative 3 to what power? 11th. And it'll be a 13C11. Put it all together. That's why they throw those types of questions on the ACT. Okay. All right. Any other lingering issues with 12 that we spent like forever on? Yeah, because then we had robots. Robots were fun. Did you guys enjoy the robots?
I was walking the track and there were people in the bus, robots were up there.
Yeah.
And it was like, look, there's ones in town, like they aren't like robots. And like one kid was like, well, those have guns, and I was like, no.
TJ, what do you got? From 12 to? Darn 20. That was just 8. Oh. I gotta remember. That means I have to remember what it looked like. It looked like. Oh wait, it would be on the internet. That was Friday, right?
No.
Bless you. Bless you. How many ways can 4 distinct positions be a relay race be assigned from a team of 9 runners? Is that going to be a combination or permutation? Give me permutation, and how many runners are there? 9, and how many do you want? 4. Well, you had your other hand there, you just didn't see it. Because your peripheral vision wasn't working. It was here. You went, oh, there's 9. So then 9 would be 4. Good times. Hey, good work. Let's do some probability. Probability. Good chance you might know how to do this. Oh boy. Hey, I need a coin. Everybody got a quarter? Everybody got a nickel, penny, dime, something? Oh, all right. So, here's a quarter. Heads or tails? The probability that you get this right will determine whether or not you can get into the room. Call it. Heads or tails? Should we let him in anyway? No. He's got to pass though, so we might be all right. You lose. Yeah, well. Well, you were running way late today. Anyway, probability. So the probability, as you guys all know, probability of some event. And I'm going to start writing it a little bit different than you might have seen. A lot of times what they do with textbooks, and for most instances, when they talk about probability, they put P of an event. For our example we just did with Sawyer, I said, what was the probability? He said heads. And we would write it like that, the probability of flipping a coin and getting heads. Well, when you're talking about probability, it's always going to be the ratio of the favorable outcome over total outcome. Bless you. Total possible. So probability of flipping a coin and landing in heads, well, how many ways can the coin be flipped and land heads? One. And how many total possible ways are there when you flip a coin? Okay, and that's what you're looking at. I know that you've all seen this. I think. You don't know. Yeah. Bless you. Well, hopefully the robots didn't take it all out. You're controlling your minds. You're saying, brains. I just went to zombie, I guess. I have no idea. So probabilities, you have probabilities are always going to wind up within a specific range. Probabilities, a probability of some event will always range between 1 and 0. Probabilities will never be negative. Probabilities will never be greater than 1. They can equal 1 and they can equal 0. If a probability of something equals 0, that means what? It's not going to happen. The probability of an event equals 1. It happens. It will happen. It's gonna happen. Like the probability of
equals 1 equals 0.5. Hey, we'll do a coin.
Yeah, there is. There's a really cool app. It'll run probability. What do you call it? Yeah, it does the simulations on it. Like it's doing experimental versus theoretical probability. We'll talk about all that stuff here later. It's pretty cool. What? Wait, what? Anyway. Yeah, you guys know this. This is easy. So, There's a difference between what's called a theoretical probability and an experimental probability. An experimental probability is just that. It's the probability, if you sit there and flip a coin 100 times, you might only get 43 heads and then 57 tails. So your probability of heads and tails might be different than it would be theoretically. But in the long run, things will even themselves out. So the more you run that simulator, the more it tallies it up, the more it will approach its theoretical probability. Theoretically, correct. Okay, and that's the idea. So you will hear these terms where an experimental probability is what your observations are. So it's what you observe. Think of it as so it's like when Lofthouse walked in and we flipped the card over. The probability of him picking the correct card is 1 out of 52. Well, he picked the right card, so his probability was always at that point, if he stopped, 1. He wins. I know, right? And then what was it? Maggie in 12th hour, when she guessed her card right off the bat, and then the next one she got wrong, then her theoretical probability changed from 1 to point to half, and then she got it wrong again, basically wanted to be the third. Got it wrong again, it was 1/25th. And what'll happen, not 1/25th, to 1/4. What'll happen is that in the long run, your experimental probability should approach theoretical probability. Correct. It's very true. It's very, very true. But then you start dealing with the probability of guessing 3 correct in a row. Then you're really getting, then you're just getting all crazy. Correct. It would be actually pretty easy to figure out. What's the probability of guessing the correct card? Let's see. So we know that if we do an alpha y equals, we get a fraction bar, correct? So that's your probability of getting one of them. Now, the probability of getting it again, if you put it back into the deck, would also be 1 in 52. Then the probability of getting it correct again would be 1 in 52. So basically, it would wind up being all to the. Oh, this isn't going to work. I didn't put parentheses on it. Sorry. Seriously, I hate this thing. So it's a snowball's chance, but it does happen.
7. That's pretty high probability of 0 to 1.
The -6. So.
Pretty impressive.
So what you're saying is there's a chance.
Ignore the -7.
So that's what? 1 little, 2 little, 3 little spots, 4 little, 5 little, 6 little spots. Anyway. You roll a 6-sided die whose sides are numbered 1 through 6. Convenient. Find the probability of rolling a 4. 1 out of 6, okay? So when we say probability roll 4, how many ways can you roll a 4? 1. How many possible are there? 6. Means? Oh, you lose. All right, ready? What's that?
Oh, no.
No. Okay. What is the? How many odd numbers are on a die? 3. How many numbers are on a die? What's the probability of rolling less than 7? Because they're all less than 7. So, oops. What happens when you get multiple die? 2 dice. Now, for some odd reason, and I don't mean odd as in like numerical odd, as in like weird. For some weird reason, this is where most students go. They have a really hard time understanding the idea of what happens with your roll when you roll 2 die. Now, yeah, what happens here is that when you have 2 of them, think of it as that times table. So if you think about it, you can roll a 1 on the first die, a 1 on the second. What I'm doing here is writing out possibles. Wesley, come on. Now, what I was doing here was writing out all possible combinations when you roll 2 die. You can get a 1 and a 1, a 1 and a 2, a 1 and a 3, a 1 and a 4, and so on and so on and so on. Now, what happens here is how many total possible outcomes are there? There's 36 of them, okay? There's 36 total possible outcomes. Now, when you start looking at it, what's the most common sum? What's the most common sum? 7. 7 is the most common sum. If you look at that, what's happening here? 1 and 6, 2, 5, 3, 4, 4, 3, 5, 2, 6, 1. You have 6 possible ways to roll a 7. Then after that, the next common would be rolling either a 6 or an 8, so on and so on. So if you've ever looked at a Monopoly board, when they have things on multiples of 7s or multiples of 8s, those are the ones that most likely you're going to land upon. So as you go, if you start playing Monopoly, buy anything and everything that are on multiples of 7s and 8s, because you will win. Now I forgot to ask Mr. Fontana for this, but Mr. Fontana does like Excel. I don't know if you knew that about him. He's kind of likes making spreadsheets and stuff. Because it's what you do. And he made a spreadsheet of a simulation, the probability simulation of working through Monopoly. It's pretty flippin' awesome how he made that thing work. So I'll show you guys that tomorrow. We'll show you that time. Oh, of course. So anyway, what'll happen a lot of times with problems, they'll say, what's the probability of rolling a sum greater than 8? Well, if I say the sum greater than 8, am I including 8? No, so I'm looking at sums of either 9, 10, 11, or 12. So I would add those up. Sum of 9, 10, 11, or 12. Well, those would be, here's my 9s, 10, 11, and 12. So let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 out of 36. And then I always simplify my fractions, and the calculator does it. You get 5 out of 18. Okay. It's very, what's that? It's one of those things that when you're dice, I'm never going to ask you for rolling more than 2 6-sided die. So it's a really easy thing to think of. When you start thinking about sums, just think, okay, if it's got to be 8, well, that means that can be a 2 and a 4. So you start with one of them, like, all right, so 1 and, or 2 and 4 would be, or not 2, 2 times 4 is 8. Hello. So 2 and 6. So it would be 2 and 6, 3 and 5. Yeah, and go start looking for patterns of that. And then you remember you can flip it because the first die could have been a 6, the second one could be a 2. So, not really. It's a matter of knowing how to write it and go. Even if you had to write this out, how long does it take to write out this? Oh, it's so long and awful. Blah. So in this case here, when they start talking about what is it, craps? I've never played it. I'm not really sure, but I know that you want it. 7s and 11s are good. I think 7s and 11s are good. 1s are bad. Well, Google the crap state. Experiment where we did this. Sometimes we'll talk about statistical probabilities. This is very common from what I've seen in some of the SAT questions. Nina's been coming in and asking some questions on some SAT stuff. And there were some statistical things out of the charts I remember seeing. Those juniors, did you guys see statistical charts on the SAT? I know in her practice ones they had some. They're really easy to use. In this example here, they're saying, what's the probability the person is 24 years or under? So what you're looking at is, where are they 24 and under? Here's your total. That would be your numerator, 94,507. Out of total possible would just be the sum of those 4 things. It's really, really easy to work with tables and charts with probabilities because you're just literally reading the information and pressing buttons in the calculator to fraction. Okay. Yeah. When they say they're at least 45, does that mean they can be 45? Yeah. Are they going to be older than 45 or less than 45? Very good. So if I want to do at least 45, let's be over total. So I would take that. And that would have been these two, so 55. Yeah. Again, this is nothing that you wouldn't have been able to figure out on your own. It is really, 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 really easy to work with. Okay. Really easy. What else was there with cards? They will start to throw card stuff here now as well. Yeah. For example, if I want to say what's the probability of selecting a jack? How many jacks are in a deck? Out of however many, and then you just simplify the fraction. It's not. The card stuff that they throw in here, we'll get to the idea of combinations mixed in with it, with probability of getting a specific hand. We'll get to that, but probably not so much today. What's that? But we also do this. Geometric probability. This is not the unit circle, this is geometric probability. When you deal with geometric probability, you're looking for, remember we talked about this before, it's favorable area over total area. Yeah, buddy.
Oh my God. Is that what you have professional?
Yeah.
I'm like Cupid. Aurora Lockhart. Anyway, so if you're finding geometric probability, you're talking about finding the favorable area divided by the total area. But, so let's say I want to land in the bullseye. How do you find the area of a circle? Pi r squared. Good. So if the radius is 3, what's the area of the circle? Is the answer up there? 9 pi. Very good. Now, then you have to figure out what the area is of the total circle. So you have 3 plus 1 plus 2 plus 1 plus 2 plus 3. 3, 6, 9, 12, and 12 squared is. So we have 9 pi over 12, or over 144 pi. Really easy stuff to work with. The formulas, the stuff I'm going to give you, it's not going to be horribly bad. It's going to be real simple formulas of shaded regions that you guys have all seen. All right. Oh, it's there.
How much time do you spend making these? Can I shoot one just with a knife? Would I trust you? You don't want it.
It moved me. That was good timing for that one. You won't get this guy anything. No, it's not. Joking. I hope you
Can I try?
do. I just want to win one time. Hey, find the probability of landing in the orange. Reddish. Right. You figure that out.
Oh, in the orange? I thought yeah, which orange? There's two. Not the middle one.
It doesn't make a noise as much as I want it.
I don't know.
Poor Caleb's like, I'm gonna get hit in the head. You know, I think I might bring a Nerf gun tomorrow.
Oh, yeah.
That would probably work better. Yeah. My children have. I'm bringing a Nerf gun tomorrow. I gotta ask Lockhart if he'll let me. No, you shouldn't have followed you and everybody else has to. I want to get my bullseye because I want you to hear what it says. And then like Bible hack, and just wear like around my I don't see what I think about this way. You're doing better. It's no. You're supposed to be finding the probability range in the orange. This was way from the old song. All right. Anyway, so oh look, I hit it. Neil, I did the bullseye. Flip the arrow. You did it. Flip the arrow. What we could do is shoot it at.
Watch this.
Caleb, go up there. I'm ready. I'm ready for you to shoot an apple. Do it, Caleb. Go, Caleb.
Hey, Sawyer.
Do it, Sawyer. Someone has to. You didn't realize what's going on there?
You sit here.
Can I have it over you?
No.
Why not? You don't trust me?
No.
That's a lie.
No.
This is a wise decision.
All right. So back to this one. When you're doing this, sorry, I can't have all of them. When I said the probability of landing in the orange-ish color thing, so you had 3 different rungs you had to figure out. When you're doing shaded region things, remember you're doing total, subtract out the whole in this case. So the total here was 3, 4, 9 subtract 7 for that one ring. So you had 81 pi subtract 40. So when I'm just gonna write them in here. So 89 subtract 49 is what? 12? No, 12.
He's doing the outside.
So that one is 32 pi. And then this was 6, so it'll be 36 subtract 9. What's that? No, I went from here to here. Subtract 16. There's your 20. And this was your 9. So then you had 32, 20 is 52, 61, so it'd be 61 pi over the, 144 we said? And then simplify it out. All right, what we're doing here is we had to find the area of just this region. And that region has a radius of 3, 4, 6, 7, 9. So this had a radius of 9, but then to just get this ring, we had to subtract out the radius of 7. And you have to do that for each consecutive circle. And that's, yeah, it's been a while since you've seen it. So I try to keep with circles and like a square inside of a circle or a triangle inside of something. It shouldn't be anything too weird. I forgot. All right. So, but again, remember.